So we'll get right into it. Our first speaker this afternoon is Bramus Van Damme. He's a man with three passions: HTML, CSS, and JS in those orders. Before he joined Google just recently, in fact, he signed up for this talk here, not a Googler. That's why we have so many Googlers here now. Accidental. But before this, he spent 8 years as a lecturer talking to mostly high school, college sort of people here. So I think that we'll be able to match their intellectual capacity. So let's go ahead and give a warm round of applause for Bramus Van Damme.
Wow. Thanks. Yeah, lunch was great, right? Everyone, yeah, okay. You can clap that up. The lunch was great. So, as mentioned, my name is Bramus. I'm a Chrome Developer Relations Engineer, and I'm on the CSS UI and DevTools team. The mission of our team is to help you more easily build engaging and frictionless websites. So if you do find anything difficult to do with CSS nowadays or with HTML, feel free to reach out to us so that we can start the communication in the CSS working group or with the Chromium engineers or whoever to make your life easier. But of course, we need your feedback. So as Rachel mentioned earlier today, please file bugs so that we know something is going on or that you want it to be prioritized. I'm on Twitter. If you want to follow me there, I mainly tweet about CSS stuff, front-end stuff, also JavaScript from time to time. And I also run a blog, bram.us. On there, I collect some interesting links and I also write my own posts. If you want to follow it, subscribe to RSS, or is that not your thing, the posts are also syndicated to a separate Twitter account. So the talk of today will be the CSS Cascade, a deep dive. If I'm honest, I wanted to name it something else when I started. I wanted to name it Cascade Layers, because this will be the biggest chunk of this talk. It will be about Cascade Layers at layer, which Rachel already hinted at. But you can't explain Cascade Layers without explaining the whole cascade. So that was named the CSS Cascade, a deep dive. And since I'm a diver, a deep dive kind of makes sense. So also, if you have any questions about diving, come ask him. And yes, I once did get attacked by a fish and blah, 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 but that's not the subject today. The subject today is this little piece of code. It's a fairly simple bit of markup. It's about a password input. It also has an ID. And you also see an element attached style there, namely color blue. But in our style sheet, we also see 3 CSS rules that also select that very same element. And they also have a color declaration. So all 4 of these color declarations, they are they want to try and set the color. My question now is, how does the browser know which color to apply? Is it the element attached one? Is it the first one of our CSS rules? Maybe the last one? Is it the loudest one? Well, that's where the cascade comes into play. Because the cascade, it gives us this answer. Now, I could give you the official formal definition. This is the one from the spec. I'm not going to read it to you, because if I'm honest, it's a bit technical and it's also a bit difficult to parse. I prefer this more simple definition, namely this one. The CSS Cascade is an algorithm that determines the winner from a group of competing declarations. Competing declarations being all those color declarations that we see there. And then the CSS Cascade says, hey, you know what? That one right there, that's the winner, and that one is going to set the color. Cool, right? These are the steps of the cascade. So these are 5 steps. Now, this is without layers just yet. It's noted there at the top right, really tiny, without layers just yet. So cascade layers will become a block inside of the scheme somewhere. Now, how does the cascade determine that winner, or how does it go through these steps? Well, let me reorder it a little bit. Because what the cascade does, it goes through the first step, and it says, hey, origin and importance, can you determine the winner? If that's not the case, it goes on to the next step, namely context. And there it asks the same question. Can you determine the winner for me? If not, next step, until, for example, say specificity determines the winner. Great, here's your winner, and then the succeeding steps will no longer be checked. So say context would return the winner, then all those other steps will not be checked. So that's the basic thing about the cascade. And it also explains why we always see this type of photo. I'm a non-native English person. I speak Dutch, I speak Flemish. And it was like, why do I always see this photo? Well, cascade, that's like French for waterfall. It's also English for some type of waterfall. And in the center here, what you see there is, it makes sense. It takes 5 levels before the water hits the bottom. Whereas on the right-hand side of the photo, it only takes 1 level before it reaches the bottom. So our CSS Cascade works in a similar way. Cool, right? Now let's dive into each and every one of those steps. Origin and importance. The spec says, well, the origin of a declaration is based on where it comes from and its importance. If we look at the browser, we have 8 different origins. And we can rank these. Namely from a lower priority at the bottom and then the highest priority at the top. Rules that are in a higher priority, they will win from rules that are declared somewhere in an origin with a lower priority. The first 3 that we have, normal user agent declarations, normal user declarations, and normal author declarations. Those are the base 3. Normal user declarations, those are the styles that come with the browser. The background is white, the text is black, base font size 16 pixels, Times New Roman, links are blue, and if you visit them, they're purple. Well, that all goes into the user agent style sheet, and it's a separate origin. Do note, there are differences between browsers. So the user agent style sheet of Chrome, for example, is not the same as the one in Safari or the one in Firefox. So there are like little differences in there. Normal user declarations, these are declarations that the visitor of our website can set through their preferences. Now, as Jeremy already mentioned this morning, not all browsers support this. For example, Firefox had it in there, and they like threw it out, if I understand correctly. So yeah, it's not supported everywhere. Something that would go in there is, for example, a person who is visually impaired and says, hey, you know what, that 16 pixel font size, I want it to be bigger. I want it to be 32 pixels because I want everything on the website to be bigger. Well, that will go in there. And since it's part of an origin with a higher priority, it will win from the user agent style sheet. So it will be 32 pixels. And then a third layer on top of that, that's normal author declarations. Authors, that's spec lingo for developers, CSS developers. So all our styles that we write, well, most of our styles, but just all our styles, just to make it work, they go in there and they win from the visitor preferences, and then they also win from the browser user agent style sheet. Everything okay so far? All right. You can see this in DevTools, by the way. This is an HTML5 kitchen sink. It's like an example with all the elements in there, and I inspect a search input. And at the bottom there, in the styles pane, we can see which styles are applied, and it also gives us a hint about these origins. Let me make it a little bit bigger. You see the line there in between both? That's like the distinction between, hey, the top part is separated from the bottom part. And there on the right, it says, well, this bottom part, that was found in the user agent style sheet, so in the lowest origin. And then the thing at the top there, it says the name of the style sheet. Well, here it was an inline set of styles, so that's why it has this hash. It was generated by CodePen. And what DevTools also shows us here is that the user styles that we have declared, they win from the user agents, the author styles, the author styles that we have declared, they win from the user agent styles. Our padding, the user agent one, it got overridden by our own padding, which we set. If you know something about specificity, you might find this weird because, hey, whoa, the specificity of the selector there at the top that you used, that I used as an author, there's like a lower specificity from the one that was used in the user agent style sheet. Well, that doesn't matter here, because in this first step, the cascade only takes a look at what's the origin and what's the importance. So that's why our padding of 4 pixels wins. What happens if you use important somewhere? You might think, well, we have these 3 origins there. Inside of the origin, an important one will win from a non-important one. Inside of the origin, that's not the case. What the cascade does instead is it takes these 3 normal origins, and then it flips them in reverse and stacks them on top, like this. So you can like put a little mirror in between there. Normal author and an important author, normal user, important user, normal user agent, and important user agent declarations. This also makes sense. You might be wondering, wow, why would they do that? Well, this makes sense. The controls on an audio element, for example, they always need to be visible. So that goes into the user agent style sheet, the one that ships with the browser, and it has an exclamation important added to it so that the controls will always be visible no matter what you try to do as an author. To round things up, we also have the animation declarations. They sit in between there, between the normal ones and the important ones. And then at the top, we have the transition declarations. So transition declarations has the highest priority, and then animation fits somewhere in between. This makes it interesting, by the way. You can, in theory, and in practice, write like an infinitely running animation, and it will always be applied on top of all other CSS is applied, except when an important is used, because then it's part of another origin. Practical example, the same one as I showed you in the beginning. Which one will win here? Well, we'll take a look at the origins. They are all author origins, because I wrote them. But then there's one important one in there, so that's from the important author origin. So that one will win, and the rest will not be applied. Cool. On to the next step. Context. I won't go into details about this because this has to do with custom elements and shadow roots and stuff like that. But what you do need to know is, well, for normal rules, the declaration from the outer context wins. So the one from the outside, that one wins from the style in the inside. And for important rules, it's reversed. Again, like it's the flipping of the origin. The same thing happens here. If there's an important in there inside of a different context, then it will win the inner context. Third step, element attached styles. There the spec says, well, you know, the declarations that are attached as a style, true style attribute, they will win from CSS rules that are in a normal style sheet, like in a regular style sheet that you will load. Again, a practical example, we have our color blue there. That's an element attached style. We have these three CSS rules also in our style sheet. Well, they don't matter because the element attached style, they're on the right. That one will win. So it will be blue. Wow. And then specificity. This is like my favorite step of the Cascade, because you might think, well, specificity, it's about those numbers, right? And the Star Wars figures, I learned it that way. It was Malarkey who posted that like 18, 20 years ago or something like that. I learned it that way. But turns out that I didn't know everything about it, because there are some caveats that I didn't know at first before making this presentation a long time ago. So specificity. The spec here couldn't be simpler. The declaration with the highest specificity wins. But how do you calculate specificity? Well, that's a difficult part. So let's dive in, right? Let's dive in. Specificity. You can check out all the rules here in the specification, or just follow along with this presentation and you will know everything to know about specificity. Specificity is expressed as a triad or trio or triple, three things, A, B, and C. By default, specificity is 0. So you start with no specificity, 0, 0, 0. Let's give him a color to make things interesting, because I'm going to add some selectors in there just to make it like visually interesting. 0, 0, 0, that's what we start with. Star, or the universal selector, well, that has a specificity of 0. If you see a star somewhere, don't take it into account, specificity of 0. An element selector, that's one in the C class. So you add one in the C class right there. A class selector, that's one in the B class. The same goes for a pseudo class, that's also one in the B class. And then an attribute selector, that's also one in the B class. And finally, an ID selector, well, that's one in the A class that you add there. And you can start combining you can start building your selectors. For example, if you do sidebar.title, well, one in the A class, one in the B class, and so forth. The combinator that you use, it doesn't affect this. So here we have like the direct child selector, the direct child combinator. It doesn't affect the specificity. So you can add a plus in there, just a regular space, the greater than sign. It doesn't affect any of the specificity. And then we start combining and counting, right? Oh, we see 3 elements, 1 ID, 1, 0, 3. We see some more clever combinations, and we use that. Now, say you have two selectors, and you have calculated the specificity. Well, the spec says this, the selector with the high specificity, that's the one that wins. So which one wins here? If you're into JavaScript, this is the compare function that you can use. And you can derive like the meaning of it. First, you compare the A part. If that's the same, then you compare the B part. If the B part is the same, then you compare the C part, and then else they have the same specificity. So what we do here is first we compare the A part. The blue one, we match it against the blue 0 over there. Well, 1 is greater than 0, so the one there on the left, that one has the high specificity. Fairly easy, right? Do note specificity, I've mentioned it, it's a triad, it's a triple. You can't combine the numbers together. So the one on the left is not 100, and the one on the right is not 103. Because in our decimal system, 103 would win from 100, but this here is not the case. First, you have to compare the blue one, compare it against the blue 0 over there. So the selector here on the left, that one still wins, even though there are 10 classes in there. So if you see an article somewhere that talks about specificity as being one number, it's not correct, close the tab. And yes, I know there's still a post somewhere on web.dev that does it that way, but it's on my backlog to fix it, so no worries about that. So here, the one on the left, that one wins. Cool. Example again, or same example, the same password inputs. We have these three rule sets there. We take a look at the selectors. We calculate specificity. Oh, which one is the winner here? Yeah, it's the one in the middle. That one wins. So the color will be lime. Woo! Cool. Now there are some exceptions, of course. It's CSS after all, right? There are some exceptions, some special cases, namely is not and has. These calculate specificity in a different way. I have the selector right here. UL and then the direct child li, and then is either ID highlighted or active. So this snippet here at the top, it can be rewritten as the bottom. It will select the same elements, but the specificity is calculated differently. Here in the bottom part, we have two selectors in one selector list. So we calculate this specificity and this specificity independently from each other. Whereas with is, well, something funky happens. We take a look at the is part, and the spec says, hey, you know what? From those contained selectors in there, namely highlighted and not active, calculate the specificity of both. Or if you have 3 or 4 or 5 in there, whatever, calculate the specificity of each. We end up with these numbers. And then from these numbers, from all of these numbers, take the one with the high specificity. So our ID highlighted, that one is a higher specificity than our .active class. So that's the one that counts. And the specificity of the whole is part, that will be replaced by its most specific argument. We also have those two over there, UL and the LI. We add them up, so the specificity of this selector right here, that's 102. The same is for has, and the same also applies for not. Not a cool thing that was added to CSS recently. Where is another special case. Again, an example, the where selector right there, it has the same result as is, so the selector that we had before on the previous screen, but specificity, again, is calculated differently. Namely, the whole where part, the specificity of it evaluates to 0, 0, 0. We have the UL and the LI in there, 002 plus 000 equals 002. Where is a great selector, by the way. It allows you to keep the specificity of stuff really low. So you can do colon where, and then in between the parents say A. That will allow you to select all A elements, but without any specificity. Amit wrote a reset using where entirely, if I'm not mistaken. Was it you? It was a lab, yeah. Adam uses as well. All right. So where is like a really, really great thing to keep specificity low if you need it. And then end child and end last child. Of course, there are exceptions on the exceptions. That one is also very interesting because not many people notice, but you can do 2n plus 1. That's quite commonly known, but you can also add like a small off part in there. So this one selects in the li and then one of its children, namely an odd or an even one. I always mix those up. I think it's an odd one. That is either a div or with the class .highlight. So it allows you to do a selection within a selection. This selector is only supported in Safari, unfortunately, at the time of writing, I was going to say, right now, at this very moment. For the end child part, what do you do there? Well, again, you have the two selectors in there, part of the selector list. You calculate specificity of each. You keep the one with the highest specificity. That one counts. But don't forget end child itself. That's a pseudo-class selector. So that's also one in the B category. 0, 1, 0. Then the li we also have on there. Add them up together, and we end up with 0, 2, 1. If you're having issues with calculating specificity, if you think, wow, why? There's this handy website. It was made by Kilian Valkov, creator of Polypane. You just chuck in a selector in there or a selector list. Yeah, now's the time to take a photo because it's a wonderful website. You chuck a selector list in there and it will calculate you the specificity of each selector, but it also explains you why. So here we have end child. Well, it says that's one pseudo class. Oh, we see 3 elements. The where, well, that's 0. So it explains you the why with it. It's a great tool for educational purposes. If you want to calculate specificity within your own code, I've created a package for that. It's @Bramus/specificity. There were some other packages available, but these packages, they wouldn't work with level 4 selectors. For example, not, where, and has, they wouldn't include them. This package does that for you. You import a specificity object from the package. You do specificity.calculate, you pass in a selector list, and out comes an array with all specificity instances. And then it also has some convenience methods, like for comparing 2 specificities against each other, which one is the greatest, which one is the lowest, and so forth. And that was specificity. Wow. You all with me still? Okay. Because this is the graveyard shift, right? The one just after lunch, everybody's like, oh, I ate too much. Then the last step of our 5 steps, so layers will be added here later, but our last step right here is order of appearance. The last declaration in document order wins. So say it's part of the same origin and same context, same specificity, no element attached styles was before that, same specificity. Then we check the document order. The last one in document order wins. Well, whoop, that one right there, Lime, that's the one that wins. Yay. And that was the Cascade part of this whole talk. Now, we're going to talk about Cascade Layers. Because Cascade Layers is like this new and exciting way on how we can organize our styles. We get slice up our style sheet into several layers, and then we can reorder those layers. And each of those layers has a different priority. I think that's pretty cool. But first, let's take a look again at our Cascade. If we're really honest with ourselves, we're mostly struggling with specificity or order of appearance. Because most of the time it's part in the same origin, same context, no element attached styles. So we're fighting with these two. A few examples. This is part of a reset that says, hey, if an UL has a class attribute set, apply some margin padding and no list style, nice. But if I as an author write this piece of code, it won't be applied because the specificity of the one used in the reset is higher than the one that I wrote. We can work around this if we encounter this, oh, open up DevTools. Oh, that's why it's not applied. Okay, we need to bump up the specificity. So we add a UL in there. Works, but yeah, not that feasible to do. This is from a carousel component. You drop the style sheet in there, some JavaScript, you use it. Yay, it works. But then you want to change the appearance of slider item. Also won't work. You can either bump up the specificity again to make it win from there, but if we're honest, we do this right. We slap an important on there and then, yeah, it works. So that's part of a different origin, that's why it works. But also, again, not something that we want to do, because if we later on want to overwrite this one again, we also have to use an important. We are forced to use it. Third example, some utility classes that I have there to left align, center align, text align, and then also a card content with text align left. Now imagine that I have a div with a class card content and then a class uTextCenter. Will the text be left aligned from the card content or will it be center aligned from uTextCenter? Who thinks left aligned? Who thinks center aligned? A lot of you think nothing. Nice. The text will always be left aligned. So it doesn't matter how you order the classes in your markup. The text will always be left aligned because it comes last in document order. Same origin, same importance, blah, 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 blah. Okay, order of appearance is the one that counts here. You can solve this by switching the order of your source code, but that's not always feasible or always possible, especially if you work in a big team. This is something that you do need to know when you're working with utility framework like Tailwind, for example. The order of your classes inside of your markup has no effect on how it will be. It's always the order of the CSS code that has the upper hand when it comes to order of appearance. So yeah, specificity, order of appearance, we kind of have a problem there. Like, what if we didn't need to worry about it? What if there was this magic step that says, hey, you know what, specificity, order of appearance, it doesn't matter because I already picked a winner. Well, that's where layers come into play. It's an extra step in the cascade that fits right in between, right before specificity and order of appearance. And that way, if our layers step can determine the winner, we don't need to worry about specificity, order of appearance inside of that, from something inside of another layer. So pretty cool. I've already said this. This is like the definition of Cascade Layers. With Cascade Layers, we get to slice up single origin styles, so styles in one and the same origin, into several layers, and then we also get to control the priority of each layer. We do this using the add rule. This is a new add rule that's available. It's available in all browsers. I will tell you also later on. Add layer. The link here is to a blog post, but you don't need to read the blog post because you're watching this presentation right now, so just follow along. This is our example again, the one with the reset, where we had to bump up the specificity of the bottom selector there. Well, add layer solves this and does it like this. Animation. Wow. It says, hey, you know what? The top part, that's part of a reset layer. And that reset layer lives all by itself. And then we have another layer, namely layer components. That's also another layer. And they are like shielded from each other in some magic way. But I will explain it to you. Because Cascade layers are ordered by order of appearance, but they are also given a priority. So if this is the order of appearance in our style sheet, so this is our style sheet, right? And then inside of it, we have an add layer reset block, and then we have an add layer base, components, and utilities. This is the declaration order. So our style sheet reads from top to bottom. But then the priority order, well, that's not the same order. It's flipped. Because the first layer that is declared has the lowest priority. And a layer that is declared later, that one has a higher priority. So components goes on top of that one as well. And utilities goes on top. So everything that's in the utilities layer, that will always win from something that's in the component layer if it is like a competing declaration. For normal rules, the Cascade layer with the highest priority wins, which I just mentioned. So that's why this example here wins. The Cascade looks at all of these layers. So it was part of the same origin, it was part of the same context, no element attached styles. This new step, layers, I have to look at the layers. Layer reset gets the lowest priority, then base, then components, and then utilities. So the components layer, the thing that is declared in there, that one will win from our reset layer, which was declared earlier. So that's why this selector right here, that one will target the element and the declaration will win. Yay, nice, I like this. So yeah, crown. That's why I think layers are like a great addition to the Cascade. It's supported in all browsers, so it's been in Chromium since version 99, so that's Chrome and Edge. Firefox version 97, and then Safari since version 15.4. And the orange numbers that you see there, well, those were like the pre-release versions, where they were either behind the behind the feature flag or in a pre-release version. So that's an important note to make here with this. You as a developer, you can like download pre-releases of browsers, flip some flags, and try things out before they are like shipped to the main audience. And that's the time for you to test things out and also to like discover bugs, file some bugs, ask questions, mostly directed. Well, you can either like ping me or Adam or Yuna or whoever, or like reach out to the CSS working group and say, I ran into this problem. It's not working as I expected it to be. What's going on? Or a browser bug. That's also possible. Now, of course, it's CSS. There are some caveats and some quirks with it, some things that you need to know, like the finer details. So Cascade Layers in depth. Here we go. Layer name reuse. You can reuse layer names because the spec says the layers are sorted by the order in which you are first declared. So we have here base, then components where it is declared, then utilities, and then again components here at the bottom. Well, we are reusing the name. We are not redeclaring it. We are reusing it. So the content will be appended to it. So this code snippet right here on the left, with these two blocks, the contents will be merged. It's the equivalent of this snippet right here on the right. But this makes it pretty cool. If you're like a separated team and lots of people working on it, if somebody has set up the layer order up front for you, you know, oh, I just have to write something. I'm going to wrap it inside an add layer block, and I know it will fit in there with the rest of it. I think that's pretty cool. Anonymous layers. A layer does not need to have a name. So you can use add layer and then wrap the contents in there. But if you do like a second add layer, well, that content, it won't be appended because it has no name. So it doesn't know like, should I append it or whatever? It creates a new layer. So these here won't be appended. Do note. You can predefine layer order. This is like a really good addition to the spec. I like this one. And because we have a problem right here. If this is our Cascade Layers style sheet, our style sheet using Cascade Layers, declaration order on the left. And then on the right there, we have our priority order. If we change some of the order in our style sheet, whoa, the priority also changes. So we're kind of screwed there, right? Well, there's a solution for that, namely the add layer statement. The add layer statement allows you to pre-define the layer order that needs to be used. So you declare them before everything else happens. You put it at the top of your style sheet. And there's some caveats with that. You can't use it like with some other add rules before or after them. So my advice is just put them at the very top of your style sheet and everything will be fine. And that way we have declared them at the top. We said, hey, first goes reset, then base, then components, then utilities, and then the contents of our style sheet, they follow. If we reshuffle some stuff inside of our style sheet, no worries there, the priority remains the same. I think this is really cool. Oh, another one. Yeah. External CSS files. We use libraries from time to time. They come with external CSS files. Sometimes we can include them in our own style sheet, or sometimes we just refer to them using link href and so forth. But here, for example, this is where we have the style sheet and we have placed them with us in our project. We can do add import, and then we can add an extra layer onto there. So at the top there, we have the add layer statement. We define the layer order. Then we say, hey, you know what? These external style sheets, import them and place them inside of this layer or that layer or whatever. And then we have our own styles underneath there in a layer base. If you are linking the file through a link element, there's a layer attribute that you can use. So it says, hey, load it up into the reset layer. One problem with that is, older browsers, well, at this moment, none of the browsers support this attribute. So they will basically just ignore the attribute and load that style as an unlayered style instead of loading it into the layer that you define there. The solution to that is to use an extra media attribute that says when the add rule, add layer is supported, only then conditionally load this style sheet. This add rule here, that's also a new extension to add supports. It's been confirmed, it's been formalized, so it's an official proposal, but it's not implemented in any browser yet. So this is future speak, but hopefully it will land soonishly. Unlayered styles. Wow. What happens if you don't use a layer? If you have like a regular style? Will it fit in? Will it go at the top, at the bottom? Well, unlayered styles, the spec says unlayered styles have the ultimate priority. So unlayered styles always go at the top. No matter where you place your unlayered styles, they always will be at the top. Like that. We're almost there. Hang on. Layer nesting. Yes, you can nest layers. I find this interesting. For example, we have a theme layer, and inside of our theme layer, we define a light layer and a dark layer. So again, these layers here internally, they have their own order and again, their own priority. So layer.dark will win from layer.light. We also have some regular CSS rules in there as well. So this is possible. How do you target? How do you append to a nested layer? Well, you use a dot notation. If you've been writing JavaScript before, this seems obvious, right? Inside of theme, you have dark, and then the content will be appended to that. Important. There's a lot to tell about layers, I know. What happens if you use an important? Well, remember our origins were like we had the 3 origins, and then if you use an important, the 3 origins themselves got like flipped and mirrored in reverse and stacked on top. Same thing happens with layers. If you use an important somewhere in a layer, they get stacked on top. Now, this visualization is not entirely correct because the top part, the one that use important, they are also part of a different origin. They are no longer part of the normal author origin. They are part of the important author origin. So if you bring back to our visualization that we had there, these two, well, we can basically like replace them with our Cascade layers, like this. And this is the whole priority stack. I always ran out of screen estate there, but it fit in just nice. So this is how like the whole origins thing works. Rolling back layers. Not many people notice, but you can use the revert keyword to roll back a declaration to lower origin. You can do the same within layers. So instead of using revert, you use revert layer. So any a.normal will not be the hot pink, but it will revert to the previous layer, so namely lime. So all the a.normals, they will be lime colored in this example. And all browsers, this is like the last thing to tell you about these Cascade layers. What happens if you use layers in an older browser? Well, these are the browsers that support it, but what about their older versions? It's not that good. You say, oh, add layer, I don't know it. I'm just going to throw it away. So you end up with a problem there, because you have all these unlayered styles that need to go on top of some other styles, but they are missing. It's like building the 10th floor of an apartment building, but the 9 floors below you are not there. That's a bit of a problem. Of course, it can be solved. This is a simple example. So we have our target, unlayered styles. That one will win from layered styles. Then we have our layer below that. Again, target color green. We can rewrite this. We can cheat, because a browser that doesn't understand layers will just skip to the next part of the cascade, which is specificity. So if we cheat by bumping up the specificity on our selectors, we can kind of make it work. This is an ID selector with the ID of the pound symbol as well, but you need to escape it because otherwise the parser breaks. So this is one ID selector that you have in there, because as I mentioned, not the specificity of not, we calculate it like a special way. We take over the specificity of its most specific argument in there. So if you do it that way, in a browser that does understand layers, that one will work. A browser that doesn't understand layers, well, here the specificity will win, so it will have the same result. Of course, you don't need to type this all yourself. There's a polyfill for that. Oh, I'm running ahead of myself. So this is the result, right? They don't understand it. What happens with it? Well, they like rewrite the whole part so that everything becomes in processed, unlayered layer, and then your code will work. You don't have to write it yourself, as I just mentioned, because there's a polyfill available. This is a post-CSS package that you can use. It's for it's post-CSS extension that you can use. You load up your style sheet with layers, and out comes the rewritten thing with the crazy ID selector in there, and that one will work. Practical, because I know it's all been like a bit of theoretical right now. How would you start with Cascade layers? say this is your style sheet that you have right now. You load in a reset, you load in some third-party styles as well. What I would recommend you to do is when starting to use layers is add the layer statement there at the top so that you define the layer order up front and then load in those styles into their own separate layer. Your own load in those third-party styles into their layer. Your own styles here, well, just keep them unlayered because they will always win from the layered ones. And this solves the problem that we had, right? The reset being too overly specific or the third-party library being too specific. Well, we kind of solve this because our own layered styles will win. If your project grows and grows and grows and you're doing something like IT CSS, well, then you can like start writing your own layers by extending the layer statement and writing your own styles like that. So in summary, this is the Cascade. 6 steps, not 5, 6 steps by now, with layers being there right before specificity and order of appearance. Do note, one big warning to do with this, if it's part of the same layer, then it moves on to the next step, then you do still need to worry about specificity or eventually order of appearance. So you just can't discard the two, you still have to know about them when the styles are part of the same layer. This is how it's done. You have your declaration order, and then you have your stacked order, like your priority order. So it's in reverse, and unlayered styles, they have the ultimate priority there at the top. If you want to read more about it, this is the post that I already mentioned, but then these two here, they are very good resources as well. So on developer.chrome.com, you have a blog post on Cascade Layers as well, using similar visualizations. It's written by Yuna. And then on CSS Tricks, you have an article written by Miriam Suzanne, the person who like wrote the whole spec together with Tab. So yeah, who better to get your info from than the person who wrote the spec? So that's also a great resource as well. And that's it. Now we move to here.
That's the speech zone. This is the question zone. All right. So we did get a number of good questions today. So we'll just jump right into the audience questions. First, are there any predefined layer names or, if not that, conventions that you think we should be supporting in our own layer usage?
If I'm not mistaken, there are none, but there was a discussion about disallowing not as a layer name. I'm not sure about that. I think it was decided upon last week or something like that.
Yeah, we've got a few reserved keywords, but they're not being used. They're just being not used.
Yeah. So you can't name your layer not, for example, because not is like a keyword somewhere else within CSS. And then the layer order, well, I think the classics ones that we already use are like a good thing. Reset and then third party. It's like generic. And then if you've been doing the IT CSS dance, well then, yeah, the layers were already defined for you. So you can just take over the names and use them in your project.
On the subject of third-party stuff, we got several questions actually about the reasoning for why unlayered styles are placed after all the layered styles. Specifically, like if unlayered wins by default, then libraries that aren't using layers presumably would win by default over your layered styles. So what are we doing about that?
Yeah, this has been it's a discussion that has been going back and forth within the CSS working group, because at first the unlayered styles had like the lowest priority, and then later on it got reversed, that decision. The key thing there is that to know that it was written in such a way that you as a developer do not need to worry about the selectors that somebody else wrote. So you can safely load in a reset style or whatever style into your own project and know, hey, you know what, my styles, they will win. I don't need to battle specificity or order of appearance. If you do load in a project that doesn't use layers themselves, well, you can always load it into a layer yourself. So you add import, name of the CSS file, space, then layer function, and then you add the name into there, and it will be part of a layer that you get control.
And that's to say, as part of the history there, yeah, we've gone both ways over which one should be unlayered, which unlayered should be very weak or very strong. We ended up the way we did because The thought was the most common use of layers, at least initially, when you're upgrading a site that's not using them right now, is going to be setting up defaults and resets and things. And those all need to be lower power than all your standard rules on the page. So we figured, hey, we're going to be wrong either way. And so this one is probably slightly less wrong to do it the way that it's currently defined.
One addendum with that, there is talks about that you get to control where the unlayer style should go. Some statement or some whatever, but it's still in flux, so that you can decide, oh, my unlayer style should always win, or they should always lose. But it's not formalized.
I think we've banned the word initial as well as a layer name, specifically because we might use that to let you put the unlayered styles explicitly in. Final question then. So a lot of the examples you gave were pretty like heart-pounding examples of old specificity clashes and all the terrible, terrible things we had to do to fix them. The weird libraries we had to do, the strange hacks, they're terrible reminders of a worse age, a less civilized age. Layers are going to fix these, but are they just useful for fixing the old bad CSS, or do they enable new good patterns to emerge that weren't possible before?
Wow, great question. I think we will see how it evolves. Like it was mentioned earlier today, like OCSS and BEM CSS. Those are mainly conventions, but you weren't limited by the convention. If you did something wrong, there was no way that you were corrected, and a mistake could happen really easily. So perhaps in the future, we will move away again from using all these extra classes and simply start relying on what's the DOM order, and you do end up with selectors like aside, ul, ali. Well, no worries, it's in a layer, so it'll win or it'll lose.
All right, thank you very much, Bramus.
Thank you.